viewers, today I discuss this important topic in real analysis. Especially this topic is infinite series and how this infinite series works for. Today I discuss, and let's watch this video without skipping. Infinite series, and infinite series means that these terms of these expressions which we have learned in senior secondary level and expressions and this is of the form, if we take in this manner, if u1, u2, u3, and that will goes to up to infinite extent, and if we are taking as nth level term, that is a un, it's a finite level terms and then goes up to infinity, infinite extent, and simply we are writing in this notation as un, and this I, that's a subscript variable, and if we are taking not I, it is a n runs from 1 to up to infinity, and that is in the cases, or simply that can be written as summation of un. So in this manner we can take it in this form. This is called the infinite series, and if we are taking as nth partial sum of this series, that is called the u1, u2 up to un, and if that's a remainder term, we can take that's a remainder term, that is a or nth partial sum of the series, that is, it can be written as u1, u2 and up to un, that is called the nth partial sum. And now we are taking this rth sum of the series, and how this rth sum can be find out. And if we are taking if the remainder term, and if writing this notation as Rn is equal to u of n plus 1 after nth term. So nth term after nth term, we started with u of n plus 1th term, then u of n plus 2th term. So in this manner we can write as u of n plus pth term, and that is called Prn is notationally written as pth partial remainder. So in this way you can write. And now f is as n tends to infinity, as n tends to infinity of then nth partial sum that is called Sn, that mesh goes to a finite limit as n tends to infinity. That is, in other word, we can write it as limit n tends to infinity Sn, that will be S. So that can be a series, it is a finite, and if S is not a sum of the normal sense, that's the limit of the sums, hence we can write it. On the other hand, it goes to plus infinity or minus infinity, then the series goes to said to be a divergent if it goes to plus infinity or minus infinity, and it is a finite cases, so it is a convergent in these cases. So it is a convergent case. And if Sn tends to infinity or minus infinity as n tends to infinity, then is called divergent cases. Obviously, it is divergent, and this result if Sn tends to infinity or minus infinity as n tending to infinity, then the series is divergent. So this will provide a basic idea and basic sense of a convergent and divergent series. This is a preliminary version of infinite series at beginning levels, and now in the next parts I discuss this important and many series of especially in this sector of infinite series, and in the next section I will discuss. And now keep watching this video till the end, and before finish up, once more remind you to subscribe the channel and press the bell icon to get all the notification and latest update.